And welcome to the stage.
Yeah, so today I hope you're having a great time, and I also hope that our presentation will not change that. We are going to talk about performance. But before that, let us quickly introduce ourselves. So here's Helen. She's our senior technical solution consultant with background in development, software architecture, stand-up comedy, and Spryker.
That's me, thank you. And here is Ivan. This is the second time I see him not in Zoom, and I do like to see you in 3D version. So he's our project technical lead, and he's in charge of Customer Success Room. If you're one of the lucky ones that never heard of Customer Success Room, this is the place where we're keeping the most tough and complex Spryker cases. So he's in charge of that. So, I would like to tell you a teeny tiny story from my past. Previously, I was receiving emails from my customer and partner developers, something like, the website is slow. Nowadays, I'm receiving the website is slow, fix it ASAP. And I was thinking if it's possible to change this type of email to something like this. The website was slow, but we found the problem and fixed it by ourselves. So, as Ivan says, usually, every developer can make a system performant, and today we would like to prove you that as well. So,
Yeah, our plan for today. We already introduced ourselves, and next we are going to align on what performance is or could be to be on the same page, and introduce our 5-step approach we are using for troubleshooting Spryker applications, and the use cases on how we use it exactly in practice and how can you use it. Then we discuss the popular or most common performance problems we see in Spryker projects, and then we will try to summarize and discuss some next steps. So, Helen, what is performance?
So this is the most boring slide of the presentation, but I'm here to help you out. So performance can consist of 2 different parts. The first part is the customer or user feeling when they're like saying, okay, the product detail page is slow. So that's the one part. The other part is standardized parameters, like time behavior. So how fast actually the PDP loads, or resource utilization. So for example, the CPU load is like 80% or something. And then capacity, how much your system actually can handle. And for that, you have some product quality standards. You can check them on ISO. Link is there. We will not tell you more about this here. Ivan?
Yeah, but unfortunately, sometimes there is a gap between those points, and it's beneficial to ask some questions, like how exactly does it feel for end customer, like how the system performs. Does it just feel slow or fast? And then how exactly it measures in numbers? What about concurrency? What about the exact amount of milliseconds? And eventually, how it translates to your monthly bill? Helen?
So this is the interactive part of the presentation. So the problem appears and how to change that email from we found a problem, fix it ASAP to email we found a problem, we fixed it. That's it, just a notification. Do you have any ideas about that? I hear somebody said create a support ticket. Unfortunately, we cannot because we have to help to actually fix those support tickets. But I see Ivan raised the hand before.
Yeah, we analyzed a lot of success room cases and understood that we are repeating over and over the same process, and we would like to share it with you today. Helen, can you help me with that?
Of course I can. So the first step of this 5-step approach is zoom in or zoom out the problem. So for example, customer is coming with the problem, everything is slow. So in this case, we need to zoom in to understand what exactly is slow. Are we talking about product detail page, product listing page, checkout? And what is slow? Are we talking about 5 seconds? Are we talking about 1 second? Sometimes it's the opposite. Sometimes developers can come with the problem, okay, the Jenkins jobs are slow. And then when we're trying to zoom out to understand the business problem, there is no business problem, and sometimes the optimization is not even needed.
The next step is collecting the data, basically collecting any available data, any evidence from APM tools, CloudWatch, whatever cloud provider you have. And for the next step, which is
For the next step, we just generate the hypothesis. So everything that we collected so far, the business problems, the collected data, we're trying to analyze it by ourselves or with support of our colleagues and generate the hypothesis, prioritize them based on the possibility or the probability, how probable that problem is there.
Yeah, And it's all needed for the next step, to actually test hypotheses that you gathered, that you prioritized. And you can test it in various ways. You can create the proof of concept pull request patches, or you can change environment, like cloud environment. You can experiment with all the available tools you have. The goal is to just understand whether or not it resolves the problem. Helen?
And the next step is to repeat the process. Sometimes, unfortunately, all those steps does not resolve the problem or does not resolve it fully. So what we need to do, we need to repeat it and repeat it and repeat it. Collect more information, collect more data, generate more hypotheses, maybe ask your colleague, maybe have a walk, whatever helps you out. So this is the framework. Even question to you, do you think this will help us to resolve all the problems that we're having?
I think it should help to resolve a lot, but still it's possible when after several iterations you are stuck. Then where we recommend to contact us to get a second or third or fourth opinion, and discuss your previous iterations, and to analyze what can be done better. Helen? Now I'm going to discuss the use cases. I show you the stack queues that some of you may be already faced with. And just a brief explanation, queues is the backbone of Spryker application. Many of you know that, and it's crucial to have it running smoothly. Again, let's try to apply this approach to this problem. The first step, basically, we call it zoom in, zoom out, but in a nutshell, it's understanding what's going on, what is perceived problem. Like usually, it can be translated to the changes introduced from data import or manual backend changes are not propagated to the storefront rapidly. It can be hours or days, but we want it in minutes. And the methods for how we actually do that, we can ask people, we can look into system behavior. But the important thing, we should not optimize something that is not important for the business. The next step is collecting the data. And for this, we have two main sources, like RabbitMQ and all the details it can provide, and the Jenkins UI, jobs output, and the RabbitMQ statistics, such as total amount of messages, amount of incoming messages, speed of incoming and consumption, and also correlated with AWS data, like logs. Then we can generate the hypothesis, and there can be several. It's important not to have only one, like not enough resources, inappropriate configuration, or custom plugins. And eventually you have to test them according to priorities. In this case, we were trying to increase resources because that was the most obvious thing, and it basically did not solve the problem completely. Then we also tried to increase or decrease batches, and that was the first iteration that helped us a lot. Then actually the splitting the queues or configuring worker limits, or like having more workers or less workers, and also checking the custom plugins. Eventually, what we saw here is the before and after. Here, before, you have millions of messages, and RabbitMQ system basically stuck on processing them. After several iterations, we were able to achieve something like that. Well, a lot of messages, more than a million, processed within minutes. And that was a success for this particular problem. But I'm wondering, Helen, maybe we have some more examples.
Of course, we do have more. And guys, I see that you're getting a bit tired. For my next case, I need to ask you. So my customer came to me and said the website is slow. Did you have this case? Like put your hand up into the ceiling, not into the sky. Okay, not that many actually. I was expecting something more than that. So I had a customer that came to me with this specific request. Of course, we were trying to use our framework. First in zoom in, so what is website is slow. And in this specific case, the checkout was taking 4 seconds to respond with 12 items in the cart, but the expected behavior was 1.5 seconds, and everything else was actually quite good, so not everything is slow. So method, how did we find out? We just talked to the customer. And what is important, we don't want to optimize something that is not important to the customer or does not have any business influence. So the second step was collecting the data. Here you cannot see, but this is the graph from the Blackfire. You can use any New Relic or AWS or Blackfire or any other tool. This is just the sample that we use for this specific case. Let's try to zoom in. So we were trying to just follow the red path of the Blackfire that it shows us. Here we didn't see anything, and this is something that we start to see something was happening. Let's zoom in. So in this specific case, the execute apply scheduler was started to call persist price product 80 times. Before, we had only one execution, and here something started to happen. So we started to generate hypotheses what was inside that code, because we didn't have the access right away to the code. So the hypotheses were the heavy custom logic, the third-party calls, and the multiple operations in the loop, or the n+1 problem. So we got the access to the code. We started to actually analyze the code, and we find out that there were no heavy custom logic, no third-party calls, but we had a lot of n+1 problems. So something was happening in the loop. What we did, we found that in our POC, or proof of concept, and of course this is the simplified version of the code, I know, we just moved it out. I know it's still the simplified version. Of course, we had to do a lot of things behind the scenes to actually change the executing one by one to the batches, but still, technically, this is what we've done, right? So then the Blackfire allows us to do the report and then comparison the reports. And this is the comparison of the report of all the changes that we did in the POC, and in the end, we got the result minus 75% of the time. So repeating. Of course, we did several repetitions of this framework for that specific problem, because n+1 problem was not just in one point of the website, but in several points. And in the end, we managed to reach 1.5 seconds that the customer wanted, and we fixed the website is slow problem. So did we reach the goal? Yes. So we can actually stop. Do we have more?
Great job. And that's actually 2 examples, but you can extrapolate it on almost any problem. And we are going to show you the most popular, the most common problems that we unfortunately see on Spryker projects. And the first one is session logs. I would say it's not a problem by itself. It's just, I would say, a byproduct of the multiple parallel requests that are too long within one single session, but for majority of your customers under load. And the way to resolve it, it's better to basically concentrate on solving other bottlenecks within the web scope. So then, like I showed you on the example with inefficient worker configuration, sometimes it's not that clear that you should decrease batch sizes, for example, or split queues, because sometimes it feels counterintuitive, like I would increase batch sizes 10 times and it will be faster. But in reality, you consume all resources and basically application competes with the systems and you get much worse performance. Then the info log, that's maybe very simple, but we see it a lot. It can consume up to 99% of your background job process, and basically the system spends a lot of time just dumping text that nobody will read. And the slow external systems. That could be like obvious things, payment gateways, shipping, tax calculations. The problem is when you are calling those systems. Better not to do it in a web scope. Helen, can you help me with some other examples?
I prepared several more as well. So I wanted to put here thousands of repetitive operations n+1 one more time, because we wanted to emphasize that n+1 problem can appear not just with SQL queries, but with any type of logic. So for example, slow external systems execution or heavy business logic. So n+1 problem, this is something that we see quite often on the project, unfortunately. The next one is heavy SQL queries. I put them here together because sometimes when we're trying to fix n+1 problem, we're ending up with another problem, which is heavy SQL queries, when we use a lot of joins and the query that we optimized is actually executing sometimes even longer than original n+1 problem. So here we really need to find the balance and test it out and see the results. The next one is Redis keys commands. So Redis official documentation says that we should never use keys on production. I would not even recommend to use it on staging, because quite often you can just push it on production and forget about it. But then if you see that Redis is slow, please check if you're using the keys. And the last but not least, heavy OMS operations in the scope of the web request. So sometimes the checkout can be quite slow for the customer, right? After the customer clicks the button, place the order, and then when the customer is actually released to the success step. OMS is actually quite a complex topic that can take another easy 30 minutes. But here, if you see that, that the checkout process is slow, in the moment when we're trying to place the order, please go and check if you don't have any heavy OMS operations at the start of the OMS and then try to release the customer as soon as possible. We have all those cases in our public documentation and even more. And of course, if you have any questions, you can ask us afterwards. And how to fix these problems, know them and do not introduce them to your project.
Yeah, that's kind of obvious solution, but I want to emphasize that sometimes these problems are not appearing just by itself like single problem. Sometimes they came in groups, like slow external systems lead to session logs, or like heavy OMS operations during the web scope also contributing to session logs. And like the info logs in the background lead to the inefficient queue processing, basically slowing down all your order processing. So I would say that here we can see the group of two type of issues. But again, if you know about them, it's very quick to check and avoid them. So let's try to recap. Today we showed you how we kind of summarized our experience and use it in the 5-step approach, like we call it, to troubleshoot and not only performance problems, basically any problem in Spryker projects, and also showed you the most popular or most common issues we see. Even if they can look like obvious things, it's still important to know about them and know how to avoid them. Helen, what else did I miss?
I would like to take over here. And as Ivan likes to say, every developer can make a system performant. And I truly believe in this. And I hope now you believe it as well. So thank you very much for participating to this session. And what we wanted to say additionally, that we have exclusive expert consulting vouchers for free 2-hour consulting. We have just several vouchers, so you have to be fast. And if your performance issue is really interesting, we will give you this voucher and we will support you with this 2 hours consulting. You can find it with me or in our expert services consulting booth, if I'm not mistaken the name. And thank you for coming.
Questions? QR code too fast?
Oh.
Can we get the QR code back? Other questions about this topic? Yes, Vasily.
Hi, yeah, nice to see you on stage. I wanted to ask, because in your examples, hi everyone. I wanted to ask, in your examples, it's like customer coming to you, to Spryker, and says, I want checkout to be 1.5 seconds, yeah? Does Spryker has any golden standards of how fast checkout should be or how fast PDP should open? And if you do, does Spryker actively monitor these values and even maybe suggesting customers vice versa that, okay, looks like solution is too slow, let's do something with that?
So it looks like it's a question about monitoring, right? And looks like I also missed to emphasize that monitoring is important. And like Alex Galic mentioned already, and some other famous people said that you can't improve what you're not measuring. And of course, we are measuring a lot of things, both on the environment side and application side. And our team can notify you about the environment-related issues, but there are application-related issues as well sometimes, and application developers should be aware how to monitor them, how to react on them. Helen?
Can I take over here a bit as well? So regardless of numbers that we have in our demo shops, so far I never saw a project that did not customize anything from the demo shop. And that's why this is important to monitor your specific project and your specific case. This is one part of the problem. And the second part of the problem is actually talk to your business and understand what is the desired output, right? Because if we do not know that, even if we measure it, but we do not know what business wants, then it does not make sense. And at the same time, if we know what business wants, but we don't measure, it does not make sense as well. So this is a combination of something that has to be implemented on each and every project, I believe. Maybe a question to you, Beck, do you have that on your project?
Well, yes. I mean, we talk about these values and try to optimize performance.
Perfect.
So
Thank you.
Thanks for answers.
I think to be efficient, if this is where the customer starts complaining, then this is your golden standard, right? Just below that. Not all at once. No?
If
Then-
you will have questions
Yeah.
later on, you can find us in the expert booth. Don't be shy. Come to us. Ask any questions.
Thank you, Ivan.
Thank you.
Thanks,
And
Alan.
expert
get
consultant
the
voucher
vouchers.
for
Yeah,
free
vouchers.
2 hours consultancy, but we don't have many of them. We have actually just several.
And if you want
so
to bribe Helen, sweet stuff works very well.
not
We don't
anymore.
oh, that was only for the hackathon?
Yes, that was only yesterday. I'm good
Only on
today.
Wednesdays.
Just interesting performance cases.
Good. Thank you.
Thank you.
Thank you.